Hi everyone and welcome back to Life Technologies channel, and thank you for watching. So today we are exploring how you can use BGP local preference to control how you want your traffic flow from one AS to the other. So we've mentioned that the biggest advantage of using BGP in your network is the ability to use BGP path attributes to control how you want your traffic flow, both inbound and outbound. So BGP is giving you that flexibility of using its path attributes to control the traffic flow in the network. So as you can see in the network, we have the client network, and the client network has to have access to the internet. And for it to access the internet, it has to go through other networks, ISP1, ISP2, and ISP3. So from our trace that we did before from PC1 to PC2, we saw that traffic from PC1 is flowing from PC1 to R3 to R1, and it's preferring the lower parts via R6 to R9, R10, R12, and then PC2. But then maybe we have a preference for the traffic to flow via ISP1. So this one can be achieved using different path attributes. We can use AS path, we can use MED, but then the focus of this lab is to demonstrate how you can use BGP local preference to be able to control the outbound traffic from our client network to the internet. So the objective is to ensure that our traffic from PC1 will flow to R1. Then when it reaches R1, it has to use the upper path of R5. And then it can go all the way to PC2. So this is what we'll be demonstrating in this lab, but before we go into the lab, we need to understand what local preference is. So local preference, it is a BGP path attribute, and this path attribute indicates the BGP preference of a device, and it only helps to determine the optimal route when traffic leaves an AS. So it's only used to determine the path when we are talking of the outbound traffic, not the inbound traffic. So when a BGP device obtains multiple routes to the same destination address, but with different next hops from different IBGP peers, the BGP device prefers the route with the highest local preference. So the highest local preference will always be preferred. So if you are having two routes, one with a lower, another one with a higher, the route with the highest local preference will be preferred. So, and the local preference attribute is not exchanged between ASs. It's only exchanged between IBGP peers. It's never advertised to external ASs. So when you are getting a route from external AS, it will not have any local preference because it's exchanged. It's not, local preference is non-transitive. It's not exchanged between ASs. And if you don't change the local preference, then the default local preference is 100. But you can manually configure local preference attributes. And this is what we'll be demonstrating in this lab. So you can see that in this setup, we have the client network, and the client network is multi-home to two ISPs, ISP1 and ISP2. And then it's connecting to the internet via the two ISPs. So let's say, for example, you are learning one route from ISP1 and you want to control the traffic flow, and you're also learning the same route from ISP2. You can see that you have two destinations on the internet. You can use local preference to ensure that traffic to one destination follows one route and the traffic to other destination follow the other route. So it's like you are trying to load balance traffic using local preference. So you can see that we are setting the local preference to 10.11.00 to be 120 on switch A, and we are setting the local preference to the same destination to be 60, so 120 will be preferred. And then for the other subnet, we are setting 80 for 1022, and the other side we are setting 200 for 1022. So when traffic is leaving from client network to the internet and the destination is 1022, it will be preferring the ISP2. But if it's going to 1011, then it will be preferring ISP1. So this is just how you can use local preference to ensure that you have control over the outbound traffic that is flowing from one AS to the other AS. So for the configuration part, first we need to ensure that we are able to match the subnet or the destination IP, the prefix that we are trying to control traffic flow. So in this setup, we are configuring an IP prefix, match internet, index 10, permit 172. So it's merging IPs in that subnet 172.200.200.0. And then we are configuring a route policy. So we are creating a route policy, and this route policy, if we are matching the IP prefix that we have created. So there is an existing IP prefix of 10, but this one should be changed to match internet. So when you match internet and then you apply a local preference of 200. So BGP 100, and then you apply this route policy in the import direction. Remember, we are changing the local preference when we are importing or when we are learning routes from router 5. Then we apply a route policy to change the local preference of the routes learned from router 5 to 200. The other side will be 0 because remember it's non-transitive, so it will come with 0. But then when this route is advertised, it will be advertised to IBGP peers with a local preference of 100. So before we apply this configuration, if we check on this router, display BGP routing table 172.200.200, you can see that we don't have local preference value on these routes because both of them are learned via IBGP. And we've mentioned that local preference is non-transitive. If we check on R4, you can see that this route is coming with a local preference of 100, which is the default value. And our target is to change this value to 200 so that it will prefer the upper path. So mention that we need to use IP prefix first to match the network, and then once we've matched the network, we need to use a route policy, and then we apply the route policy to the import direction and not the export direction because we are changing it when we are exchanging routes from A300 to S100. So we will apply these configurations. Let me just change this route policy to be so I'll copy this. I can edit from here. So these are our configuration that we need to apply on R1. And then I just need to change this prefix 10 to prefix. Then we can run these configurations on our R1. So system view, we apply. So if I display current configuration BGP, we have applied our route policy in the direction of import. So we can do display BGP routing table, same route 172.200.200.0. You can see that now the route that we are getting from R5, it's coming with a local preference of 200, while the one that we are getting from R6, it's coming with no local preference. So if we check back on R4, remember it had a local preference of 100. If we check it, now it has a local preference of 200. So the route is being advertised within the AS with the new local preference of 200. So if we do a trace, again from PC1 to PC2, you see that now it's preferring the upper path of 10, 10, 10, 1, 10, 10, 3, and 10, 10, 5. So our traffic flow is now using the upper path from R1 to R5. R5 to R7 is now flowing via ISP1 and not ISP2. And remember, this one is just controlling one-way traffic. So the return traffic could still flow via R6 because we haven't done any configuration changes to make it prefer the upper route. So when you need to control the two-way traffic, you need to apply the route policy both sides of the network. You will have to apply in S100 to force it to the upper path. You also have to apply it in A600 to ensure that it's following the same path. So this is how simple it is to control traffic flow, the outbound traffic flow from one AS to the other using local preference. And remember, the default value is 100 and the highest value is always preferred. For the configuration, you need to configure IP prefix to match the subnet or the prefix that you want to control, and then it's advertised to use it's advised to use a local preference, I mean the route policy, to control to merge the IP prefix, and then you can apply a higher local preference. And then the route policy is now used in BGP configurations in the import direction. You can also do in the export direction depending on where you are using the route policy. But in this setup, remember, if you are a network engineer and you are managing your network, you only have access to your network. You don't have access to the ISP network. So that's why it's always good to apply the policies in your local network, the client network. So guys, thank you for watching again. Remember to leave your comments, to like, and to subscribe to our channel for more upcoming videos. Thank you. Bye.